Let's try to go over this together in some detail. What we see here is the pattern for declaring a class. This is somewhat familiar by now. This is a new keyword, class, and then there is a name for it, and then there is the body. So what is a class? A class is a template for an object, and it contains all information about the operations that this object supports. In this example, we are trying to model a square, and the geometric shape. And as you see, it supports the calculation of a couple of quantities, the area and the perimeter. Now, these calculations are performed by functions that belong to the class. These functions are called methods, and they act on the data that's specific to the object. So this data would be the side of the square, and we see it here used inside the methods. But we don't have any value for that yet. Why? Because we're just defining a template for a generic square, and once we have a particular instance of a square, which is called properly an object, then we will know what the value is. But for the time being, we only have this parameter self that's always passed around to all methods defined inside the class, and self is the parameter that will automatically make the link between these functions and the actual values belonging to the actual square once we get to define one. For the time being, if you try running this code, nothing happens. In reality, you see that this code is run because you get the little execution number here, and what has happened is that you have defined the square class, which is a template for these objects, just as when you are running a definition of a function, you are defining the function, but you're not actually calling it. So in order to actually have a square object that we can play with, we need to create one, and that's called creating an instance of the object. How's that done? Well, that's done by calling the name of the class as if it were a function. You see, the class is called square, so we call the name of the class as if it were a function with brackets afterwards, and that creates a new instance of a square for us, and we can assign it to a variable. So square1 is a square object, square2, sq2 is a square object, another one, and now we can set their specific values for the side, for instance. So we can say square1 dot side is 2, square2 dot side is 3, and that completes the definition of these two objects, and we are therefore able to use the methods defined by the class. So these are the actions that we can perform on the object. We are allowed to use them on square1 and on square2, and they produce the values that we expect. So square1.area is 4, square2.area is 9, and so on and so forth. Now you see here this dot that we've seen in conjunction, for instance, with strings and with other Python objects that are already defined, and it denotes an operation that's applied to a particular object, so an instance of a class. That used to be a particular string, for instance, but now it is a particular square. If you look carefully, you may notice something strange. So here we're calling square1.area and there sq1.perimeter, and we're not putting any parameter in these brackets, but in the class definition you see that area expects the parameter self and perimeter expects the parameter self. So why isn't the interpreter complaining about it? Now the answer to that is that parameter self is passed automatically by the interpreter that takes it from that is, from the particular instance that we are working on. The way this is done is made evident, I think, by an alternative syntax that's honestly not very much used, but I think it's very informative, and we find it down here. So here we have sq1.perimeter, and down here we are computing the perimeter of sq2, but instead of writing sq2.perimeter, we are writing square, which is the name of the class, dot perimeter, and in the brackets we are putting sq2. Now that looks more like the usual type of call, right? Square, that will be the class dot perimeter, okay, we're inside there, and we're passing sq2 because we want the perimeter of that particular square. But obviously we could as well have written sq2.perimeter, that would have been the same. So this is, if you want, syntactic sugar for that longer expression. In the beginning it may look like a bit like magic because you're kind of passing a parameter that you're not passing, but you get used to it very quickly, and it's so much more convenient than writing that.